Good morning, guys. Today's lesson is going to be the start of bringing a lot of pieces together. A lot of the stuff we've been working on for the last month is now going to start to fit together. We've been working on things individually, and now we're going to have to start looking at them sort of all as one big idea. So let's go back, first of all, to our slope notes from earlier in this whole entire unit. So if we're looking at the screen here, you guys are going to be looking at notes that you guys have already taken. And we've come back to these notes over and over again. The idea of slope and the idea that slope is rate of change. So if you see that phrase rate of change means this slope. And we've looked at the slope in a lot of different ways. Now, typically when we start talking about slope, we're looking at linear equations, straight lines. And when we have kind of calculated slope, we've looked at it as rise and run. And rise and run, if you recall, was how we find the slope on the graph. So if you're given a graph, you find 2 points and you count your rise and your run. So your elevator goes up or down, and then you get out. Change in y, change in x. So that's going to be if the data is given to you in a table. And that data in the table could then be plotted as points that you would put on the graph. But that's a way in which you can calculate slope from the table is the change in y over the change in x. And then the last is the slope formula. y2 minus y1, x2 minus x1. And that's finding the slope if you're given 2 points. And we've done all of these. Now, we spent a lot of time doing it if we had points and if we had the graph. And then most recently, we just found the slope when we were looking at a table and we wanted to find the rate of change. Well, we're now going to have to work with all 3 different kinds of ideas at the same time. And so that's kind of what we're going to be looking at here is how do we look at the slope and the rate of change and then compare it in different formats. So you're really going to have to tap into your prior knowledge and all the things that we've been working on. So what I've put together here is I've put together a series of examples comparing 2 different ideas, 2 different linear equations, sometimes one in a table and one in a graph, or sometimes one in an equation and one in a graph. And we have to compare the slopes for each one of them using all of the different methods that we have. So let's go ahead over here and share screen with the dot cam as we go through this. So the first example, and these have all come from IXL. I've just copied and pasted them so we can look. We have 2 functions here. We have function A and function B, and one is a graph and one is an equation. And they want us to compare them, and they want us to find out which one has a greater slope. So does function A have a greater slope than function B, or does function A have a slope that is less than function B? Well, we have to look at each one of these for what they are. So if I'm given a graph, remember on a graph, to find my slope, I need to do rise over run. So you have to find 2 points that are on the line that fit right on the grid. So the first point I'm going to use is this one right here, because it sits right there on the point 0, 2. And then I'm going to go up the line until I see it hit the grid again. Perfect. And that's going to be that point right there. So if I start with the point on the left, my elevator has to go up, and it's going to go up 1, 2, 3. And then I get out and I run 1. So again, I rise 3, run 1. So rise 3, run 1. That means the slope 3 over 1 equals 3. Remember, we use the letter M for slope. So on the graph, I use my rise and run. Now, this is given to me in the equation where y is alone. So this is given to me in the format y equals mx plus b. Well, if you recall, when we're given the equation, the m is the slope, and that is always the number that's in front of x. So if I go back to the equation up here, there's nothing in front of an x, so that means there's an imaginary 1 there. So what does that make the m for the equation? The m is the number in front of x, so that's 1. So this one, the m, or the slope, is 1. So remember, the letter m represents slope. So this one has a slope of 3. The graph had a rise 3, run 1. So the slope was 3. This one, I pull the clue out of the equation, and the number touching x is m. So this one has a slope of 1. So is function a have a slope that's bigger or smaller than function b? And it has a slope that is greater than function b. So this would be your answer to the first one. So the idea of comparing slopes using different formats of how we've worked with it over the last month. So let's look at another example here. So this example here is comparing a table to the equation. So we have to now think back to how do we find the slope of a table? And if you remember, the slope in a table is change in y over change in x. So I am going to, within the table, we're going to say, okay, here's the change in y. So what is the change in y? Well, it goes from 7 to 13. So that's an increase of 6. And over the same period, the x goes from 4 to 7. So that's an increase of 3. So if I plug in the change in y went up by 6, and the change in x went up by 3. So the change in y over change in x is 6 over 3. So that means the slope for this one reduces down to 2. So the slope of the table was 2 when I calculate the change in y over change in x. And then for this one here, again, we're in the equation form. So we have y equals mx plus b again. So I'm looking for where is the m. And in this case here, the number touching x is 5. So the slope for the equation is 5. So is function a have a slope that's bigger than function b, or is it a slope that's less than function b? And this one here, once I do my change in y and change in x, the 2 is less than the 5. So I would pick this answer here. So the first example compared a graph to the equation. So I had to use my rise and run. And the second one compared a table to the equation. Let's go back here and let's compare equations and graphs again. So here is my mx plus b equation. So what is the m for the equation? The slope for the equation is the number that's touching x, so that's 2. And then for the graph, I have to find 2 points. So I'm going to use this one here, and there's another one right next to it, so that works out really nice. And this one has a rise of 1, run of 1. So for the graph, I do rise over run, and that equals 1 over 1. And 1 over 1 means the slope is 1. So which one has the greater slope? The equation for function a has the greater slope. So function a is bigger. Now we have to compare the table and a graph. So remember, the table, change in y over change in x. So change in y and change in x. The change in y was an increase of 6. And the change in x over the same portion of the table was an increase of 2. So the change in y was 6. The change in x was 2. So this slope reduces down to 3. And now for the graph, I need to find two perfect points. Well, the first one I'm going to pick is right here at 0, 0. That's a really nice one. And then I'm going to go up until I hit the grid perfect again, and I hit it right there. So I have a rise and a run. And the rise over run. So the rise is up 1, 2, 3, 4, 5 squares. And then I get out and run 1 square. So this one has a slope that is 5. So which one has the greater slope? Well, in this one, function B. So the slope of function A is greater than function B. Nope. The slope of function A is less than function B. Notice each one, we're comparing slopes, but we're just doing it using different formats. I want you to go ahead and try this one on your own now. You are comparing a table. So remember, table is change in y over change in x. And the equation is using y equals mx plus b. So take a moment and find the slope of the table and the slope of the equation. All right. So let's take a look here at the equation because that's the easier one. Y equals mx plus b. I'm looking for the m, or the number touching x. So in this case, that's a 1. So the slope of the equation is 1. For the table, you have to be very careful because of the negatives that are here. So if I go from here to here and here to here, if I go from -11 to -1, that's an increase. I went from -11 to -1. The change in y is an increase of 10. All right, so from here to here, it increases by 10. And then from -3 to 2. So think about that. -3 to 2. How much is that a change? That's going to increase by 5. So 10 over 5 means the slope for this one reduces down to 2. So my slope was 10 over 5, or reduces down to 2. So which one has a greater slope? Function A had the greater slope. So let's try one more here for you guys to do on your own. We're going to compare a graph to the equation. So remember, the graph is your rise over run, and the equation is the y equals mx plus b. So pause for a moment and figure out which one has the bigger slope for these. All right, let's see what we've got here. For the graph, I need to find 2 spots where it hits the grid perfect. So here's one point here, and I'm going to go up the grid until I find another one right there. So I have a rise and a run. The rise is up 1, 2, 3. So the rise is 3. And then the elevator doors open and I get out and I run 1. So the slope for function A, the slope for the graph, is m equals 3. And then for the equation, I'm looking for the m because that's what's touching the x in the equation. And in this one, again, it's a 1 because I don't see a number there. So that means the slope for the equation was 1. So which one of these has a larger slope? The graph has a slope of 3, so function A has a greater slope. So comparing slopes. So comparing slopes using the graph, comparing slopes using the table, comparing slopes that have an equation in mx plus b. And we're going to use the different ideas that we've worked on for slope to compare them. And then just determine which one has a larger slope, or they could use the phrase which one has a larger rate of change. All right, so hopefully this works out well for you guys. This might be one where you have to go back and watch again so you can see those examples and pull together all our ideas for slope over the last month. Guys, have a wonderful day, and I'll talk to you later.